Ellipses, section 10.3. There are two types of ellipses. You can have a horizontal ellipse, where that's the center. These 2 points right here are called the foci. Okay? You can have a vertical ellipse, where the foci are here and here, and the center is here. So these two are the foci. Foci is plural for focus. The definition of an ellipse is that an ellipse is a set of all points in a plane, the sum of whose distances from the two fixed points, i.e. the two foci, is constant. Okay? Now some important things to know about an ellipse. If it is a horizontal ellipse, that is your equation. X minus h squared over a squared plus y minus k squared over b squared equals to 1. All right. If it's a vertical ellipse, then we have x minus h squared over b squared plus y minus k squared over a squared equals to 1. Now, see the difference. In a horizontal ellipse, a squared is underneath the x coordinate. In a vertical ellipse, the a squared is under the y variable. Okay, that's important, because notice, it's longer this way if it's vertical, it's longer this way if it's horizontal. So that would tell you that the a value, or particularly the a squared value, is always bigger than the b squared value. That's always true, because the value for c, which is the distance from the focus point, either one of them, doesn't matter which, the distance from the focus to the center, that is my c value. And this relationship is always true. A squared minus b squared equals to c squared. So far, so good. Because a squared minus b squared is equal to c squared, a squared must always be larger. And when a squared is larger, that will fall under the x value, or the x variable. When it is horizontal, it'll fall under the y variable when it's vertical. Okay? Now, the distance, I've already told you this, the distance from the center to the focus is value c. You have two lines of symmetry on any ellipse. You have a vertical line and a horizontal line. The longer of the two lines of symmetry is called the major axis. Major axis. And the major axis runs from one end of the ellipse to the other end of the ellipse, and it's the line of symmetry. It is horizontal for a horizontal ellipse, it's vertical for a vertical ellipse. So the major axis is always equal to 2 times a, because the distance from one endpoint on the major axis to the center is always equal to A. The minor axis is the shorter of the two lines of symmetry, so it would be this one on the horizontal ellipse, it'll be this one on the vertical ellipse. That's always equal to 2 times B. Now, these 4 endpoints have special names. We call these 2 points, the 2 endpoints of the major axis, we call those vertices, and the 2 endpoints on the minor axis, we call those co-vertices. So you have foci, you have 2 foci. You'll have 2 vertices. You have 2 co-vertices. Vertices are always on the major axis. Co-vertices are always on the minor axis. All right, now let's look at an example. Let's say I give you an ellipse, and this is on your PowerPoint, slide number 14 on your PowerPoint. You are told that the foci are at 0, 1, and 4, 1. And you are told that the center is at 2, 1. So far, so good. You are also told that the 2 vertices are at -1, 1, and 3, 1. And you are going to write the equation of the ellipse that have these 2 foci and these 2 vertices. Now, if you don't know the center is easy to find. It's either the midpoint of these 2 or the midpoint of these 2. Now, if you find the midpoint of these 2, you get 2, 1. If you find the midpoint of these 2, you get 2, 1. This should be 5, 1. My apologies. I messed that up. My fault. Midpoint of this is 4 plus 0 divided by 2, which is 2. 2, 1. This is 5 plus -1, which is 4. 4 divided by 2 is also 2. 2, 1. So if we're going to write the equation of this, first of all, let's talk about whether this is going to be a horizontal or a vertical ellipse. Notice that if the foci are 0, 1, and 4, 1, notice that the y-coordinate does not change. Notice that in the vertices, the y-coordinate does not change. Only the x-coordinate is changing. If only the x-coordinate is changing, it's going to be a horizontal ellipse. Okay? So, I got to find my a squared value, my b squared value. I got to know those 2. Well, I can find a squared pretty easily because a is the distance from the center to the one of the vertices. So the distance from 2, 1 to 5, 1, or the distance from 2, 1 to -1, 1. In either case, my a value is 3. So a squared is 9. I need to find b squared. Now remember my relationship, c squared equals to a squared minus b squared. And c is the distance from the center to the foci. Okay, now how far is it from 2, 1 to 4, 1? It's 2 units. So c squared is equal to 4. So I've got a squared and I have c squared. I need to find b squared from this relationship right here. So c squared, 4, equals to a squared, which is 9, minus b squared. If I solve this for b squared, I get b squared is equal to 5. So now I write my equation. X minus h is the x coordinate of the center, 2 squared over a squared, plus y minus k is the y coordinate of my center, over b squared, which is 5, equals to 1. That's how I write the equation in standard form, given that information. All right, another type of example, a question like example 2, slide number 17 on your PowerPoint. We have x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Now, in an equation like this, typically when you're given the equation, you're going to have to find the center, vertices, co-vertices, foci, and you'll be asked to sketch a graph. All right, now where do we start? We have to first put this in standard form. It's in general form. This is called general form. To put it in standard form, we have to do something called completing the square. That is something that you've done in Algebra 1, in Algebra 2, and in geometry, but I'm going to refresh your memory. The first thing you do is you put it in this form where you're grouping your x terms together and your y terms together. I forgot my y here on my 8. My apologies. All right, now on this one, since I don't have a coefficient in front of my x squared, I don't bring anything out in front of the parentheses. So I do x squared plus 6x. Now I take half of the linear term, which is 3, and square it, and I get 9. I take half the linear term, which is 2. The linear term is 2. Half of that is 1. 1 squared is 1. Now, if I add something here, I have to add something here. So this is a 9. This is not a 1. It's a 4 times 1, which is 4. So now I rewrite this in factored form. X squared plus 6x plus 9 is x plus 3 squared. This is a 4. Y squared minus 2y plus 1 is y minus 1 squared, equals to negative 9 plus 9 is 0 plus 4 is 4. Okay? Now divide each of my terms by 4 because this has to be a 1. So now this becomes x plus 3 squared over 4 plus y minus 1 squared over 1 equals to 1. My a squared value is 2. My b squared value is equal to 1. My c squared value, remember c squared is a squared minus b squared. A squared is 2, b squared is 1, right? So c squared is also 1. Now my center is minus 3 plus 1. My vertices, now since this is a horizontal, I add a is the square root of 2, b is 1, c is 1. To find my vertices, I take my h value, negative 3, and I add to it, and I subtract from it whatever a is. So negative 3 plus the square root of 2, 1, negative 3 minus the square root of 2, 1. Those are my vertices. My co-vertices, I'm adding to the y-coordinate. I'm adding b to the y-coordinate. So this is negative 3, 2, negative 3, 0. My foci, I add the c value to the x-coordinate of my center. Negative 3 plus 1 is negative 2, 1. Negative 3 minus 1 is negative 4, 1. So those are my foci. To sketch a graph, I draw a coordinate plane. I first locate the center, negative 3, positive 1, that's the center. I put my two vertices on here, and it's going to be a sketch, right? So my co-vertices are at negative 3, 2, and negative 3, 0. This is going to be negative 3 plus the square root of 2. That's about right here. This is negative 3 minus the square root of 2. That's about right here. I'm going to do this right here. Just sketch these through the vertices and my co-vertices. To put my foci in here, I go negative 4, 1. That's my one focus, and there's my other focus. And that's my sketch. Okay. Another idea involving ellipses is the idea of eccentricity. Now the eccentricity basically is just telling you how much of an oval or how much of a circle your ellipse is. Okay, to calculate the eccentricity, and we use the lowercase letter e. It's not the number e, it's the variable e. They're not the same. This variable e is equal to whatever my c value is in my ellipse divided by whatever my a value is in my ellipse. Now, in every ellipse, the eccentricity is always going to be greater than 0 and less than 1. if E is close to 0, the more circular it becomes. All right, the more circular it becomes. If the eccentricity is ever equal to 0, you don't have an ellipse, you have a circle. If the eccentricity is ever equal to 1, you don't have an ellipse there either. It's equal to a line. So the eccentricity for an ellipse is always between 0 and 1. The closer it is to 0, the more of a circle it becomes. The closer it is to 1, the more elongated it becomes. And that's how you calculate eccentricity. All right, those are the types of problems you have to do on section 10.3.